So in this video we're looking at ray diagrams for lenses, and we're going to see that they're very similar to ray diagrams for mirrors. One of the types of lenses will parallel the ray diagrams and all the natures of the images that they do for mirrors too, and the other one will parallel the other one, but it's not quite what you'd expect perhaps. Anyway, you'll see where we're going from that. First of all, we've got our concave lens. A couple of similarities to our earlier drawings. We've still got our vertical and horizontal axes which we're using. I haven't drawn my axes particularly straight. It should be a nice straight line. Use a ruler or a straight edge, maybe the straight edge of your calculator or something, to draw these if you need to draw them in a test or exam. Our object, we're just going to put it arbitrarily here. It doesn't actually matter where the object is going to be in this case, as you'll see shortly. So the other similarity is we have this small symbol in the middle to indicate the lens. We use the same vertical axes to imagine that's exactly where all the, in this case, diverging takes place, all the refraction to change the direction of the light rays. Because remember, the thickness of the lens makes it difficult to do perfectly, but if we consider it straight on one line, we can get a good approximation. Okay, so the difference is we've got a focal length on either side, because remember it's a bi-concave lens, because it's got two sides, and same with two radius of curvatures, or 2 times of 2f. Anyway, let's draw some rays, see what we come up with. Now we know a parallel light ray from going to this will spread out as though it's coming from the focal point. Okay, that's good. And any light ray that goes through the center, the very center, that'll pass straight through. Okay, that's kind of cool. That'll pass straight through. So we can just draw that going straight through the center. Okay. Now, if we were to view this from this side, here's our eye, and you're looking. It's always tempting to draw like dot 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 to show where they're looking, but that kind of indicates that the light's coming out of their eyes when it's not really. But in any case, this observer sees the light as though it's coming from a point. Now we can't take this bottom ray here and dot 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 back, because that would appear on the same line as where it's actually coming from. But you can see from this ray up the top, the one we drew first, there is a dotted line going back, and they cross over at this location here. This is where our image is. Okay, so you would think this is a bit of a pointless lens because it shows an image that's smaller, that is, the magnification is less than 1, or we might say it's diminished. But they can be useful. For correcting lenses, for glasses and things like that. But so that's one part of the nature of the image. We must consider the rest. It's upright, so it's vertically oriented the same way as the object. And there's one other thing: is it real or virtual? And in this case, because it's come from dotted light rays, even though you can't see the dotted light ray from that ray down the bottom, it still appears to come from a point. And the image is at a position where if you put a screen there, you definitely wouldn't get an image produced. You would just block the light rays and stop them coming through. So this is a virtual image. Yeah. Okay. Yeah, that's an example of when you might use this is perhaps with, I don't know, nothing's coming to mind ready and easily. Oh, okay, fishbowl lens on a camera, so that you can see more, because it shrinks everything. You might want to be able to see more in the camera shot. So it's going to take a whole lot of, what we call that, it's a fishbowl lens, and it's called a fishbowl lens because it looks like you're looking from inside a fishbowl out. With that kind of curved view of the world and everything's distorted in that way. But skaters often use this for their skating videos because they have a long run-up and then they do a trick in one position, but they want to show a good portion of the run-up. You'll also see it in parkour and free running videos too. Okay, so the convex lens now. We want to have a look at, we'll redraw our axes a little bit better than the last one, our convex lens or our biconvex lens, and we have to draw our focal points, roughly twice the distance, and I'm estimating these, but you should measure them if you have to draw anything accurately. Okay, and we will draw with our object outside of 2F. And remember, these are a converging lens, so we would expect that the light rays will converge to a point as they come from parallel. So let's draw our parallel light ray, and it's going to refract through the focal point. We can draw our light ray that goes straight through the center as well, so we'll draw that one. Not too well, I might add, but that should pass through that central point, but you get the idea. Interesting, it's the same ray that can be drawn for the concave lens above. Let's just write that this is convex so I don't muddle my words when I'm talking about it. Now, they clearly cross over right here. We can draw our image nicely, and it's clear that the nature of the image is obvious. Well, the nature of the image is obvious. It is inverted. It's definitely smaller, which would say diminished, or the magnification less than 1. And this is a real image, because the real light rays are crossing over and are producing, I guess, an image that you could project on a screen. So it's made with real light rays. There's no virtual things going on here. Okay. Yeah, in the next video we'll draw a few more light rays, ray diagrams. In fact, we might, I'll show you the special cases, there's 2 special cases, and then we'll draw them all on one diagram to show you how they progress.